Good afternoon, students. So once again, welcome to Transportation Engineering video session. In the previous lecture, we started with a new topic, that is payment materials. So we discussed few introduction points, correct? Like what is payment, what are the different layers present in the payment, and each layer have different types of material made up of some different types of materials. All those information we discussed. So from last class, we got to know that some few major or main important materials which are used for the construction of the road. For example, is soil, aggregates, and bitumen. So these are the three major materials. So now in this class, what we are going to do is we'll start studying about those materials. So once again, we'll start with the soil first. And already I told you in the last class that soil, we are not going in deep because already we have a subject which we have studied all those information regarding soil. So basic concepts we are going to discuss in this particular class. And you take whatever the materials, what we are going to do is we are going to discuss about the material and the test which we are going to conduct on that particular material. So similarly, like we are going to take first topic is soil. We'll see what is soil, what are the types of soil, and where exactly we are going to use this soil in road construction. And we'll discuss the experiments or tests we are going to conduct on soils. And in that one only we are going to discuss, that is because of the syllabus says you need to discuss only one experiment, that is CBR, California bearing ratio test. Okay? Chalo. See, payments are a conglomeration of materials. These materials, their associate properties and their interactions determine the properties of the resultant payment. So obviously, when you take the payment, it is a combination of different materials. So the total overall, the stability of the payment or the quality of the payment depends upon the property of the materials which we are going to use. So if you are using a very good quality materials, so obviously the quality of the entire payment will be good, right? If you are using very inferior quality of materials, then obviously the quality of the payment, it will be very inferior or very weak or poor. Okay? So that's why the overall, in simple language, that quality of the payment or the stability of the payment depends upon the quality and properties of the materials. Thus, a good understanding of these materials, how they are characterized and how they perform, is fundamental to understanding the payment. So obviously, that's why we need to study about the materials. So if you study the material, study about the materials, so we'll understand how it is going to behave in the different conditions. So for suitable conditions, suitable materials can be used. The materials which are used in the construction of highway are of intense interest to the highway engineer. Soil is the accumulation of or deposit of earth material derived naturally from the disintegration of rocks or decay of the vegetation that can be excavated readily with power equipment in the field or disintegrated by the gentle mechanical means in the laboratory. So basically, soil is nothing but accumulation or deposit of earthen materials, and its parent is like the rock, and how from rock to soil is converted. You studied all these things in even soil mechanics or geotechnical engineering, and also in geology. So undisturbed soil beneath the pavement is called as the natural subgrade. Uh, Compacted subgrade is the soil compacted by the controlled movement of the heavy equipments. So that means once if you are talking about the natural subgrade, so it's nothing but like it is undisturbed soil sample, not sample, so it is a soil. So it is the foundation layer where it is not disturbed at all. So obviously it is 0.5, 0.6 meter below the road surface or ground level. And compacted, there are two subgrades, like one is natural subgrade and second one is compacted subgrades. Compacted subgrade means what we are going to do is whatever the soil is present, we are going to loosen up the particular soil. And second, we are going to compact that one for our suitable density. So like already we discussed, for if you are constructing subgrade, that subgrade ka density should be 98% of whatever the density you achieved in the laboratory. So let's start with the subgrade soil materials. So this is a subgrade soil materials. Okay, this is it will be the top layer of the subgrade after compaction and all. Still working is going on, and these are geosynthetic materials we don't require right now. The wide range of soil types available as highway construction materials have made it obligatory on the part of the highway engineer to identify and classify the different soils. Obviously, there are different types of soil particles are there. As a highway engineer, we should know the what type of soil or how much quality or quantity we should use. Broadly, the soil types can be categorized as laterite soil, muram or red soil, we can say, desert sands, alluvial soil, clay, including black cotton soil. So these are the some of the soil particles. Sorry, soil. Okay, these are the different types of soil. So from this chart, you can see there this is like X is my sand percentage DI, and in this direction there is a clay percentage, and here it is silt percentage. So you can see if it is 100% sand percentage, it is called sand. If it is somewhere around 70 to 90, है तो loamy sand बोलते हैं, and if it is that means if it is towards sand percentage. So sandy loam or silt loam, silt as a we are going to discuss. If you're talking about the silt, then on obviously 100% silt है तो silt बोलेंगे या 10% sand है तो silt बोलेंगे. So like that only different percentages of sand gives different types of silts like silty clay loam, all these things. When you're talking about the clay, you know clay is the finest particles of the soil. So you can see 100%, 60 to 100% clay है तो you can call it as a clay, sandy clay loam as a difference. Okay, this is a very simple this thing to differentiate what type of soil it is. So basically, when you see the gravel, there is a sand, silt, and clay. Correct? Anything above the 2 mm is called as gravel. Anything between 2 mm to 0.06 mm, we can call it as a sand. Within sand, there is coarse sand, medium sand, and fine sand. For that one also, they are given the dimensions like from 2 mm to 0.6 mm, you can call it as a coarse sand. From 0.6 mm to 0.2 mm, you can call it as a medium sand. And from 0.2 to 0.06 mm, you can call it as fine sand. The similarly, silt is there. Once again, the silt is once again divided into three parts: coarse silt, medium silt, fine silt, and respective dimensions also they are given. The last one is clay, that is coarse clay, medium clay, and fine clay. And anything is lesser than 0.02 mm, we can call it as a clay material. So that means gravel is having a greater diameter than sand, then which is greater than silt, and silt is greater than clay. So clay is the finest materials. Okay? So that is what they are given. Gravel, these are the coarse materials which particle size under 2.36 mm. Okay? With little or no fines. Obviously in gravel there will be no fines, otherwise it will become clay soil हो सकता है या percent depending on the percentage. Clay हो सकता है, silt हो सकता है. So like that only they are given the muram, silt, and clay. So I already told these are the finer than the silts. Like clay soils exhibit stickiness, high strength when dry, and show no dilatancy. Black cotton soil and other expensive clays exhibit swelling and shrinkage properties. So basically in clay soil, fine particles are more. Because of that one, there is more surface area. And these soils are called as expensive soils also because when it is dry, it will be very hard and it will shrink. But if it is when it is get saturated, so it becomes very like swelling आ जाता है, soil swell हो जाता है. So that's why it is called, it will expand, that's why it's called as expensive soil. ठीक है? Okay, these are some of the different types of soil. By picture, it's like these are called as coarse soil. These are like sandy, and these are black cotton soils. Okay. Okay. Next, whenever you are talking about the soil, soil compaction is a very important what I can say parameter है और प्रोसीजर है जहाँ पे फॉर रोड कंस्ट्रक्शन के लिए बहुत ही important है. Like soil particles packed closely together by reducing the air voids. See, first of all, you need to clear with the definition of the compaction, because most of the time in examination point of view, compaction is very important definition. Sometimes they may ask the difference between the compaction and consolidation. uh, for which most of the students like get confused. They will get confused and they may interchange the answers, or like they'll get confused and they may give the wrong answers, right? So soil particles packed closely together by reducing the air voids. That means in compaction, what we are going to do is we are going to apply some external force so that all the soil particles should get compacted or packed closely each other. So that how it is going to get closely each other in compaction, basically we are going to remove the air voids by providing the external force. That means you are going to apply external force so that the air void should be removed. Once the air voids is removed, the density of the soil is increased, or the soil particles get compacted or packed closely each other. So obviously because of that one, increase in dry density, the density of the soil is going to increase. Obviously, if the density increases, the especially dry density, the strength of the soil is going to increase. So maximum density depends upon compacting moisture content and also compacting effort. So obviously that whatever the maximum density you are going to achieve, so that depends upon two important things. One is water content. That is obviously once you samjo up like 1 second. So what happens is okay. Okay, what happens is like, see, even if you take some soil, if you add some water, you try to mix it, like you make it more denser. तो क्या होता है अगर कम पानी है तो ज़्यादा डेंस नहीं होता है, थोड़ा पानी और ऐड करो, देन एट सम पर्टिकुलर पॉइंट वो प्रॉपर से डेंसली आप उसको लाइक सॉइल को कॉम्पैक्ट कर सकते हो. और ज़्यादा पानी और ऐड करते गए तो ज़्यादा पानी भी हो गया तो वो डेंस नहीं होता है. So why I'm telling this one is like that compacting or to get the density, maximum density, obviously you require proper moisture content plays an important role. So that's why moisture content is important to achieve the dry density. Second one is obviously uh, compacting kaise kar rahe ho, like whether you're using like some compactors or manually or some machines or something, depending upon that one also. Okay? So that means more compacting efforts, you may achieve better density also. That is important. So this is one graph. One I hope you remembered when you conducted the sorry compaction test. So ultimately, you're going to find out the dry density and water content. So when you water content is nothing but moisture content. So by using those two data, you're going for you're going to plot the graph. That is x-axis में आप moisture content लेते हो और y-axis में आप dry density लेते हो, and obviously you're going to get this graph like this. So what happens is as your moisture content keeps on increasing, your density also, dry density also keeps on increasing. So after some particular point, some more addition of water will reduce the density. That is what I was telling. Okay? So it keeps on reducing. So that means somewhere you are going to get the peak point. So that means that particular amount of water, if you add, so you're going to get the maximum dry density. So this, whatever that density you're going to get, it is called as maximum dry density. And obviously that water content is called as OMC, that is optimum moisture content. Okay? So if we can see, this is with respect to some moisture content. So you can ask, sir, दो graph दिया है, तो what is the two curves? See, one is for then second point comes into picture, compacting effort. So that means compacting effect में light compaction भी आ सकता है, like heavy compaction भी आ सकता है. That's what I told, like how much energy you are going to put to compact that particular soil. So if you're going with the light compaction, obviously you're going to achieve less dry density. And if you're using heavy compaction, you're going to, for the same soil, you're going to achieve more dry density with for lesser OMC rate. You can see OMC is less than that one. Okay? Samjho this is 8, this is 10, this is 12. This is samjho 10% is the OMC. And here it is samjho 14% is the OMC. Even though 2% for when you're going for road construction, 2% of less water means it's a huge amount of water. So like that only the strength of the soil bhi aata hai. There are different tests you are going to conduct to find the strength of the soil. Shear test, bearing test, penetration test. In shear test, direct shear test, triaxial compression, unconfined compression. There are a number of shear tests are there. Bearing test, there is CBR test and penetration test, plate bearing test is there. As I already told before, we are going for only one test, that is CBR test. Okay? So CBR test I'm going to explain in the next class, and we can finish the soil part. ठीक है? Then we move on to the aggregate part. Hope आपको ये class समझ में आया, clear है? चलो, thank you.